What if Earth suddenly stopped orbiting the sun? Not slowed down, not drifted off course, just stopped, dead in its tracks, frozen in space like someone hit pause on the entire planet. It sounds impossible, and honestly, it basically is. Earth is currently hurtling around the sun at about 107,000 kilometers per hour. That is roughly 30 kilometers every single second, which means in the time it takes you to read this sentence, you have already traveled the distance of a marathon. So today, we are going to ask what happens if all of that momentum just vanishes instantly and Earth simply stops in its orbital path. Let's talk about why this is such a violent idea in the first place. Orbital motion is not really Earth choosing to move forward. It is a constant tug of war between Earth's forward momentum and the sun's gravity pulling it inward. Isaac Newton figured this out centuries ago. An orbit is basically a controlled fall. Earth is always falling toward the sun, but it is moving sideways fast enough that it keeps missing. Take away that sideways speed, and there is nothing left to keep missing with. Gravity wins immediately and completely. Astrophysicists sometimes describe this using the concept of orbital velocity, the exact speed needed to balance gravity's pull. Drop below that speed, and you do not get a slower orbit. You get a fall. So what would that actually look like, second by second? In the first moments after Earth stops, almost nothing visible happens. The ground does not crack open. The sky does not turn red. But every loose object on the surface that was not orbiting in perfect lockstep with the solid ground beneath it suddenly behaves strangely. The oceans, atmosphere, and crust are all loosely connected, held together by gravity rather than rigid bonds, so a sudden stop ripples through them differently. The atmosphere, which was moving at that same 107,000 kilometers per hour, does not stop as cleanly as solid rock might. The result is winds far beyond anything in recorded history. Hurricane-force gales sweeping the globe within minutes, driven purely by inertia trying to keep moving while the planet itself has already halted. Within hours, the real story becomes gravity, not wind. Earth begins falling toward the sun. At first, this is almost imperceptible, just a gentle increase in velocity, the same way a dropped object falls slowly at first before accelerating. But unlike dropping a ball from a building, Earth is falling from roughly 150 million kilometers away, and the sun's gravity, while weaker at distance, never lets go. Calculations based on simple freefall physics suggest Earth would take a little over 64 days to spiral all the way into the sun if it stopped completely. That number comes from solving what physicists call the radial fall time for an object dropped from Earth's orbital distance with zero tangential velocity. So we are not talking about an apocalypse that unfolds in a single day. We are talking about a slow, 2-month countdown, and that is somehow scarier. Here is where the dark turn comes in. Falling toward the sun is not even the thing that kills everyone first. Long before Earth gets close enough to the sun to burn, the changing distance wrecks the climate. As Earth drifts inward those first few weeks, sunlight intensity increases according to the inverse square law, meaning if you have the distance to the sun, you receive 4 times the energy. Within the first couple of weeks, average temperatures would already be climbing past anything human agriculture has ever experienced. Crops fail first. Then ecosystems. Coral reefs, already sensitive to fractions of a degree of warming, would be among the earliest casualties, collapsing within days rather than decades. Meanwhile, on the far side of this slow fall, something stranger happens to the length of a day. Earth's rotation does not stop just because its orbit did, so the sun would still rise and set, just against a sky that is rapidly, visibly growing larger and more intense with every passing rotation. Now let's push this further. The climate collapse is only the appetizer. As Earth continues falling inward over those 9 or so weeks, it eventually crosses the orbit of Mercury, the innermost planet in our solar system. By this point, surface temperatures would be hot enough to boil oceans outright, sending massive volumes of water vapor into an atmosphere that is itself being slowly stripped away by solar radiation. This is not science fiction exaggeration. Venus offers a real, terrifying preview. Venus sits much closer to the sun than Earth, and a runaway greenhouse effect there, driven by exactly this kind of vapor feedback loop, left it with surface temperatures around 465 degrees Celsius and clouds of sulfuric acid. Earth, falling inward, would be racing toward its own forced version of becoming Venus, except compressed into weeks instead of geological ages. And then comes the climax of this entire scenario, the final plunge. After roughly 64 days of falling, Earth would cross what astronomers call the Roche limit, the distance at which a celestial body gets torn apart by the tidal forces of a much larger one. Before Earth even technically touches the sun's visible surface, the sun's gravity acting unevenly on the near side versus the far side of the planet would begin to stretch it. Imagine the entire planet elongating like cosmic taffy, Mountains and oceans and continents pulled into a stream of molten rock and vapor trailing into the sun. This is the same basic physics that shredded a comet called Shoemaker-Levy 9 when it passed too close to Jupiter in 1994, breaking into more than 20 fragments before impact. Earth's ending would be a planetary version of that same tidal destruction, except instead of fragments hitting a gas giant, the fragments would simply become part of the sun itself, their atoms folded back into the same nuclear furnace that gave birth to the entire solar system 4.5 billion years ago. It is worth pausing here to ask why this could never actually happen on its own. Orbital momentum is not something that just disappears. Conservation of angular momentum is one of the most ironclad rules in physics. Stopping Earth instantly would require removing an almost incomprehensible amount of kinetic energy in essentially zero time, something no natural process in our solar system is capable of doing. Even a massive rogue object slamming into Earth would transfer momentum gradually compared to this thought experiment's instant stop. So this scenario lives firmly in the realm of imagination, a tool for understanding just how much our entire existence depends on a delicate, ongoing balance between speed and gravity that nobody is actively maintaining. It just is. Which brings us to the real question underneath all of this. We live our entire lives standing on a planet that is essentially in permanent free fall, saved only by the fact that it is moving sideways fast enough to keep missing the thing it is falling toward. That is not a metaphor. That is literally orbital mechanics. Every sunrise you have ever seen, every season that has ever changed, every moment of stability in Earth's climate over millions of years has depended on that sideways motion never faltering, not even slightly, for 4.5 billion years straight. There is something almost unsettling about realizing that the only thing standing between us and the sun is speed, and something almost beautiful about realizing that speed has never once failed. So the next time you watch a sunset and think of it as gentle, remember that gentleness is an illusion built entirely on velocity. We are not standing still under a calm star. We are falling forever. And somehow that is exactly why we are still here. But what happens if it is not Earth's orbit that fails, but the sun itself that changes? That is a story for another What If.